In this lesson, we're going to be using the law of cosines to solve an oblique triangle. We use the law of cosines when we have two sides and an included angle, or when we have three sides. So for the law of sines, you have to have a complete fraction, meaning you have to have an angle and a side across from it before you can use the law of sines. But for law of cosines, we're not going to have that. We have different information that's given. So that determines that we're going to use law of cosines. And the good news about law of cosines is there's no ambiguous case. There's no possibility of having a second triangle. So that's nice. The formulas are a little more cumbersome, but at least we don't have to check for a second triangle with the law of cosines. That's just law of sines. All right, so when three sides or two sides and an included angle are given for a triangle, you have to use the law of cosines to find missing sides and angles. All right, so law of cosines. So we've got a couple of different forms here. We have what we call the standard form and the alternative form. Okay, I would use the standard form if I'm finding sides. Lowercase letters, as you can see that over here on the left-hand side of the equation, we have lowercase letters. So I would use the standard form when I'm finding the sides. But when I want to find angles, uppercase letters, I'm going to use the alternative form. You can see the uppercase letters over here to the left of the equal sign. So this form for sides and this form for finding angles. All right, our first example says, let's look at number 11 on page 557. So if you have your book and you want to look it up, that's fine. I'm going to try and record the picture that's in the book of the triangle. So maybe I'll put it over here. I've got this triangle that looks something like this. Non-right. This is angle B. Angle C, this is angle A. So across from angle A is lowercase a, across from angle B is lowercase b, and across from angle C is lowercase c. Okay, the given information is that this angle B in here is 20 degrees. So we've got angle B, and then we've got the two sides on either side of that included angle. So A was 10 millimeters, and C is also given, and that's 15 millimeters. So we've got side A and side C and uppercase B. We have two sides and an included angle. We don't have a complete fraction, like we don't have both B's or both A's or both C's, because then we'd be using law of sines. All right, so law of cosines, wonderful. We don't have to check for another triangle. Okay, so like we did before, what are we missing over here? Well, I have angle B. I need angle A, and I need angle C, and I've got side A and C, so I need lowercase b. And it's just up to you what you guys want to find first. I'll probably find side B. So I'm looking up here. I'm going to use these formulas right here to find sides. So I'm going to look down until I find the formula that has b squared. So I'm going to record it down here. So b squared is equal to a squared plus c squared, which I have both a and c, minus 2 times a times c times the cosine of angle B. So I have got a and c, and I've got uppercase B. So b squared, a is 10, c was 15, 2 times 10 times 15 for a and c, and then cosine of what, 20 degrees? Okay, so we're going to put all that in our calculator and then find that value, and then we're going to find the square root of it. As a matter of fact, if we want to avoid doing that, what we could do is we could go right to b, and we could say b is equal to, because we're going to square root both sides, and just put all that underneath the radical. I don't need parentheses around those numbers, so 2, 10, 15, cosine of 20 degrees. Because remember, these formulas are for b squared, and you're going to have to square root them to get the value of b. Okay. And when I did that, I got 6.56447. And that's the side length, so this would be millimeters. And I did go to 5 decimal places. Just mixing it up a little. All right, so now let's find, I guess we can find angle A. So if I'm going to find angle A, I'm going to be looking up here at this alternative form in the equation that has uppercase A in it. You could have found C, which would require you're using this formula. So I'm going to find uppercase A. So cosine angle A equals, I've got a fraction, and I'm taking b squared plus c squared minus a squared. So b squared what was A, 10? Okay, sometimes I use parentheses, sometimes I don't. Doesn't matter. It's not going to change anything. 2 times B times C. These two numbers, 15. All right. So we're going to have cosine angle A equals, and then we're going to have some value here from the calculator. And I don't have that value, but you might want to do all this work right here. So whatever number you get here, then you're going to do an arc cosine to get angle A. So angle A, I did get, was 31.40055 degrees. I'll record that here. Now to find angle C, just add angle A, what we found, to angle B, and then subtract from 180 degrees. So 180 minus the sum of A and B. Okay, and I am going to quickly find this value because that is not good. Square it. So 8535457, and then I'm going to come here and do a second cosine of my previous answer, second answer. So that's where I got the 31.40055 degrees. No checking for a second triangle. Woo! Okay, let's look at number 2. Notice that the given gives us 3 sides. So we've got to find 3 missing angles. So let's find 2 angles, and then once we get 2 of them, we can add together, subtract from 180 to get the missing one. So I'm going to have to use 2 alternate forms here to find 2 missing angles. So I'll just start with finding angle A. Okay, and I'm going to go right to the formula. Cosine of angle A, fraction, b squared plus c squared minus a squared, all over 2 times the 15 and the 21. Let's grab that and change that to a fraction. Where is that? Math? Or to a decimal. There we go. Enter. Up. And then we're going to do math to a decimal. I think that's where it has to happen. Okay, and then I'm going to do a second cosine. And then the answer is the above the minus in blue. Second answer, that's where I'm grabbing it from. So angle A is 30.10823 degrees. Okay, and I'm going to find angle B much the same way. So look up to the top, find your cosine of angle B formula. It's a squared plus c squared minus b squared all over 2 times 11 times 21. Okay, you can find a value, or you can actually just go straight to second cosine of that. And I'm sure some of you guys have seen that, and that's absolutely fine too. Ah, grab that. Angle B is 43.16076 degrees. And then let's add that to angle A and subtract from 180. And I'm just going to subtract from 180 and know that my answer is going to be positive. I don't want to waste any more keystrokes. I know an angle measure is not negative. 731.01 degrees. Okay. If we rounded. Alrighty. See, I think I have a couple more examples, so let's go there. Yep. All right, what is number 26? All right. Actually, I think I'm just going to stop there based on where we're at. Yeah, and we're not even going to do these. That's with the parallelogram. This year's a little strange, so we're not even going to do them. We're going to finish by actually going and looking at what's at the bottom here, Heron's area formula. In the last lesson, we did see that we could find the area of a non-right triangle, but what happens when we don't have two sides and an included angle? What happens if we just have the 3 side lengths and of our triangle and we still want to find the area? Well, given any triangle with side lengths A, B, and C, no angle measures are given, we can find the area by taking the square root of the product of 4 numbers. S, and then S minus side length A, S minus side length B, and S minus side length C, where S is what we call the semi-perimeter. It just means you add up all 3 sides of the triangle and divide by 2. Semi meaning 2. All right, so let's use Heron's area formula up here to find the area of the triangle with given information. Okay, it's going to take a big radical. The first thing I need to do, though, is I need to find what S is. So here's your formula. Let's add A, B, C, and divide by 2. Looks like that's going to be 3.7. So that S value goes here, 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 and here. So 3.7 times 3.7 minus A. And then 3.7 minus B, 2.75, times another parentheses, 3.7 minus C, which is 2.25. I'm going to have to extend that a little. So strictly calculator work, and I got 2.57405. Okay, so I think this one's pretty short and sweet too. So once we cut those out, then we don't need to do those this year. All right, there we go.